This is the best algebra activity I've ever seen. We start with this beautiful result. The 7 means that that's a 7 by 7 square. The 4 means that that's a 4 by 4 square. So we've tiled a rectangle with these different squares. But there's a problem. We want to tile the rectangle, any rectangle, we want to tile it with squares of all different sizes. Here we've got duplicate size 4s, duplicate size 2s. We don't want that. We want all of the squares to be different sizes. The first thing you do is you hand out a puzzle sheet. This is the one that I use. We have that failed attempt with duplicate 4s down in the bottom left. And then you just let students try. And I tried this before I knew the solution to that this is actually possible. I tried this and it is hard, and your students will fail. In 20 years of teaching this activity, I have only once had grade 8 students solve this. So not an easy puzzle. And we want failure there. Now, failure is good because that motivates the next part. And that is, you can draw something like this. And it's easy to cover a rectangle with rectangles of all different sizes. But whenever you draw this, you're going to say something that sounds really strange. You're going to say, no, these are all squares. Yep. And the kids are going to say, no, they're not squares. And you're saying, oh yes, they're squares. I might be a bad artist. Yeah, I'm a bad artist. These are all squares. And we are going to algebraically assume that these are squares. That means that I, for example, can write an x and a y in 2 of those squares. What does the x mean? That's an x by x square. What does the y mean? That means that the height and the width of that square is y. What else do we know? Well, based on that, maybe, I know what we can do. And we can ask, what should I put in this square? Oh, that's going to be x plus y. What else do we know there? Oh, the square to the left. That's going to be 2x plus y. And we can go all the way around, 3x plus y. Oh, now there's a problem. What do we do here? Well, let's add this line. This is going to help because on the left side, if you just look on the left of that, that's going to be 3x plus y plus x. So on that side of the line, we know what that is. That's 4x plus y. And on the right side, well, it's the same line. So they have to be the same, the exact same. And that's going to be question mark plus y. Okay, well, what's question mark? Oh, question mark is just 4x. So that wasn't that hard. Okay, what do we know now? Think about what other square we can figure out. Oh, the one just underneath that. Okay, that's 4x minus y. Now, just take a second to realize that that's true. If you have 4x minus y plus y, that's going to be 4x. Okay, that's what we want. Good. Next, that one on the right, I think we can do that. That's going to be 8x minus y. And then underneath, we're going to have 12x minus 2y. Good. What do we do now? We're left with all these x's and y's. What do we do? What do we do? Well, one thing that you could do is you could look at the height on the left and the height on the right. Those two have to be the same. And so, yeah, we have 5x plus 2y and 20x minus 3y. So you could do that. Another thing that you could do, we're not going to do that, but that would result in the same thing. Instead, we could add this line and figure out that on the left, that looks like x plus 2y. And on the right, that looks like 16x minus 3y. So what's true? Well, those two have to be equal. Okay, yeah. And let's sort our terms. So that's going to be 5y is equal to 15x, or y is equal to 3x. Now what do we do? oh, I guess we can replace y by 3x everywhere. Good, there we go. And let's simplify. And we get this. And now we can just, we've got an infinite number of solutions. We can say x is equal to 1, x is equal to 2. We can say x is equal to anything we want. And so for x is equal to 1, then this would be the result. For x is equal to 2, this would be the result. X is equal to 3. So yeah, you can choose anything you want. I guess this would be the simplest. So let's just choose x is equal to 1. And now let's reposition it. Have we succeeded? No, we failed. But the technique was an interesting technique. Let's try that again. So now, release your students to try this. And you're going to tell them this is x and this is y. Later on, we're going to experiment with different x's and y's where we could put them. But for now, just give them that this is x and this is y. And they have to go forth and figure this one out. Here goes. We're going to step through it. So we've got x plus y. We've got x plus 2y, 2x plus y. And we just keep on going. We do the same thing that we did last time. It's that this line is x plus 3y plus y at the bottom. And at the top, it's question mark plus x. So what is question mark equal to? Well, it's got to be 4y. There we go. Okay. Now we can keep on going and finishing it off. What do we do? Well, again, you could look at the left side and the right side of this giant rectangle, the whole rectangle. But instead, we're just going to do this one. And we're going to say, okay, that's x plus 15y and 3x plus y. Those have to be equal. And what does that result in? That means 7y is equal to x. Okay, so I can just replace x everywhere I see it, and that is the result. And again, there's an infinite number of results, infinite number of possibilities, but just let's choose y is equal to 1. And that is, now let's reposition everything, get everything to the right size. Here we go. Oh my gosh, this time we actually got a solution. That works. Okay, now wonderful experience of algebra working. Wonderful. Okay, and the kids are going, wow, there's the power of algebra. Now, the question is, can you just start with x and y anywhere? We started with them here, but can you just start with them here? Well, if you do that, you get this very nicely done. You get this, but then, don't know what to do. So can we start with them here? Well, if we start with them there, we get that very nicely. We get this nicely, that nicely, and yeah, this is going to result in the same thing. We are going to be able to solve this. X and y are going to be different. Let's see. So we get this. 18x is equal to 20y. 9x is equal to 10y. Well, the easiest way to solve that would be x is equal to 10, y is equal to 9. Let's do that. And again, you find that we end up with the same solution. Let's try this again. So here's a totally different diagram. We'll put x and y there, and we'll work our way around using our same technique that we've used before. This time we have to use the technique twice. So turn off the video if you want. Try to figure out what that little square is. And it is 3y minus 3x. We'll keep going now, finishing it off. And we could check the two edges, but no, we're going to use our old technique of this here. 10x minus 7y is equal to 5y. And what does that result in? Well, we could have x is equal to 6 and y is equal to 5. That would work. So that would work. Something's funny here. And look, the 23 and 24, the 24 looks smaller than the 23. So we have to, first of all, okay, that solved some of our problems, but we've also got a minus 3 there. What the heck is that? And we've also got 22 and 19, and we've also got 25 looking smaller than 22. So there's a number of problems here, But if you just start to make this on graph paper, you actually end up with something that works crazily. Look at that. It actually works. So yeah, you had to do the -3. Something went funny there. So it wasn't perfect. And we could have said, well, it's a failure because we got a -3. Of course, you can't have a square with edge length -3. But somehow it still helped us in coming up with a solution. Okay, crazy stuff. But what a beautiful way to get kids into algebra.